Why do we continue to have low math performance? Even though we have improved curriculum, improved standards, improved testing at the state level? Well, the answer is teacher knowledge. I'm not saying anything bad about teachers. Teachers are wonderful, but a lot of them have not been adequately prepared. So there are 4 critical areas: cognitive foundations, the structural knowledge, university preparation, and psychology, how students learn. Those 4 things are so important, and it's not happening across the nation right now. So this is why we see low performance in mathematics. So I'm Dr. Jonathan Brendifer. I am the founder of the Developing Mathematical Thinking Institute. As a former teacher and professor, I studied this, went into K-12 classrooms, and focused on building these 4 things. So the research is there, it's just not found in practice. So let's break these 4 down. So the first one is the cognitive foundations. So part of that is understanding that how information comes in, short-term memory into long-term memory, building schemas and being able to problem solve and think mathematically. Now, Deborah Ball and Heather Hill have done some great work over the last 20 years on MKT, mathematical knowledge for teaching. And so what they found out that it's not just knowledge of math that they need. So that's important. You also need to have specialized knowledge in mathematics, understanding of teaching and the structures and the processes, and knowledge of students' thinking. So let's talk about these. So structured knowledge is really critical. So we need to be able to understand not just the math, but the progression of math. So the learning trajectories, the progressive formalization. We have some other research overviews on that if you want to learn more about that. But really critical, for example, is like fractions. So when you're understanding fractions in 3rd grade, and then what are the models, what's the language, what are the ideas that build from understanding fraction on a number line to adding and subtracting, multiplying, dividing. What are the different mathematical models? What's the language? So then when students get stuck, what do? Well, that's part of the problem. If you don't have that knowledge, you just stop and you go, I don't know what to do next. So then that leads into, so how do students learn? Really important idea is the psychology. So how does the brain actually work? How do we have dual functioning, where you're talking about language and problem solving, you're also talking about imagery, visual representations, and how powerful that is. Spatial reasoning. Many teachers are taught how important measurement and spatial reasoning are to really understand mathematics at the beginning and all the way through calculus. And then that leads into, well, what about the universities? They've gone through this preparation program. Well, that's part of the problem, is that they get one course. Usually it's taught just the mathematics and doesn't talk about these different trajectories over time, the different models, what to do when kids struggle. They don't take a course on psychology, one of the most critical things that they need to know. Those 4 ideas then lead to the problem of low performance. So teachers, well-intentioned, don't have any of that information. So then what do? Well, they go out, they start teaching, and they usually get a workshop. So what happens is lots of curriculum companies come in and they don't even, it's not professional development, it's really training. They train them how to use the curriculum. Find page 32. So teachers have a question, they tell them what page, what chapter to go to, where to click on their sites. That's not building their knowledge. And then there are some PD where you get from the universities, they'll come out and they'll work with staff. But the problem is that they typically are people who were a great teacher at a certain grade level or taught at one subject level. So they don't see that understanding from kinder through 12th grade. One of the things that we do at Developing Mathematical Thinking Institute is all of us are in classrooms every week, kinder through 8th grade. And so that builds that knowledge of understanding where students are and how do we actually help teachers get the knowledge. The other thing we do is we do sustained learning. So it's not just have that 1-day or 2-day workshop, we actually work with them in the summer and then throughout the school year. Understanding their standards before, during that grade level and after, so they get more of an understanding there. And then we work with them with the kids, they see it in progress, very critical. So a lot of these people who come out and work in the schools that do the workshop are well-intentioned, but they really do like projects. Like Dan Meyer's The 3 Acts. Kids focus on a story problem. It might be on water coming out of a faucet, and they'll actually go check out a faucet. Awesome, and then work on solving that problem. But a lot of these projects are great once, twice, 3 times in the year. It doesn't have that needed sustainability over time. So when you're thinking about professional development, what you need is to have somebody with that knowledge that helps your teachers build knowledge of math, math learning, students thinking, and psychology, as well as understanding the curriculum well enough, the different resources to build that knowledge with the teachers. That's when you see student achievement increase. So that low performance we talked about, that's where it starts to increase every single time. It's not when you introduce just new curriculum. And check out our other research overview, our DMT Insight, on the difference between curriculum and professional development. What is the difference in money, and what's the difference in student achievement? So one of the things that we did, so while I was a professor, I actually created a master's program for teachers. And so what we did is we took them through 7 courses where they learned the math with number, geometry, measurement, data analysis, the psychology, and then what to do with these kids that struggle, figuring out what's the progression. Like, do you understand that there's 6 major models for subtraction? And what's the first one? Then how do you progressively formalize that to get to the algorithm? These are key ideas. And so that's what we do. We bring this to the district. We work with you sustained time, maybe 1, 2, 3 years, to build this knowledge with the teachers. So they get the math knowledge and students thinking, and then how does it actually happen in the classroom? And when we do this, our achievement's they skyrocket every single time. We've had incredible success with teachers. Some of them have increased 10, 20, 30, 40% in their student achievement, in their reasoning, getting their kids to reason better. It's amazing. We took a school in Selma, Alabama from a F rating to a C+ rating in 2 years. It actually works. Just bring us in. We're gonna partner with you to get these amazing results over time. And we've put together a free Math Success Foundations course, which will give the teachers some initial ideas, and then you can bring this out. And those 7 courses I talked about at the university, we've encapsulated that, and that's what we'll work with your teachers over a 3-year period. So like, share, and follow us, and check out our website, mathsuccess.io or dmtinstitute.com.